Today, we're going to look at word problems or story problems involving sine, cosine, tangent, inverse sine, inverse cosine, and inverse tangent. So many of these examples are going to be angles of elevation and angles of depression. And so essentially what you need to understand about angles of elevation and depression is angles of elevation are pretty straightforward. Okay, suppose you were looking straight out parallel to the horizon, and you look up at a certain angle. That angle that you're looking up at is the angle of elevation, and so this angle right here would be the angle of elevation. Now, the angle of depression is usually a little bit harder for people to see and understand, but essentially, the angle of depression is the angle at which you are looking down. Okay, so this angle here in the right-hand side here is the angle of depression, not this one. Okay, that is the biggest misconception. A lot of people think that angle, the green angle there, is the angle of depression. No, the angle of depression, if you're looking straight out and you look down, it's whatever that angle is that is created between your line of sight originally and then your new line of sight. Okay, and so again, if I have to reteach that tomorrow to clarify them, then we'll take the time to do that. All right, so the first deal here, if I can get. Let's see here. All right, there we go. So the first example, all right, anyway, so it says the angle of elevation from point A to the top of a cliff is 38 degrees as shown in the diagram. It says if point A is 80 feet from the base of the cliff, how high is the cliff? Okay, so we want to let X represent the height of the cliff, and so in other words, here's your diagram. Solve for that X right there. All right, so if I want to solve for X, again, we already know the angle that we're working with. We know that X is opposite. That 80 there is adjacent. Opposite adjacent tells me to use tangent. And so the tangent of 38 degrees is equal to opposite over adjacent. Remember, I think of this as under 1, cross multiply, so X equals 80 times the tangent of 38 degrees. Okay, and if you have a calculator, you go ahead and plug in 80 times tangent of 38, hit enter, and you should get roughly 62.5. Make sure you have units on it, feet. So the cliff is roughly 62 feet tall. All right, so that is the first angle of elevation example. Okay. Again, my suggestion is we're going through here and we're working through these examples. If you feel confident, then I would go ahead and pause the video and see if you can get the answer correct on your own. And if not, then you may want to watch the video. So anyway, that's my suggestion for you. As we go through this video, I will do all of the examples, but you don't have to watch every single one. Just go through and try them on your own. It says a tree that is 40 feet high casts a shadow 58 feet long. So here's a tree. That's not a tree. There's my tree. And I know that when it casts its shadow out this way, okay, is 58 feet. So this shadow is 58 feet. The height of the tree is 40 feet. There's my right angle. The question is find the measure of the angle of elevation of the sun. So in other words, this is my angle of elevation because I'm looking upward. Okay, so they want to know what is that angle there. Okay, and so as I go through, again, this becomes, if I call this angle, let's just call it theta. That's what we use a lot for missing angles. And so if I want to solve for theta there, the 40 is opposite. The 58 is adjacent. Opposite adjacent says to use tangent. So tan of theta equals opposite 40 over adjacent is 58. It's important to recognize here I'm solving for an angle, so immediately I know I'm using inverse tan. So in order to get rid of this tan, I got to do tan -1 to both sides. Cancel, cancel. So theta equals inverse tangent of 40 over 58. And again, at that point, the calculator becomes your best friend because all you do is hit tan -1, parentheses 40 divided by 58, parentheses, hit enter, and you get roughly, the angle measure there's roughly 34.6 degrees. Okay, know what you're solving for. We're solving for an angle, so my units are degrees. Again, if you need to see that work, pause the video and go ahead and copy that down. If not, we'll keep plugging away here. There's 2 more examples that I'm going to do. And again, you can watch them all. You can try them on your own, however you feel you need to do this. But long story short, when we come in tomorrow, I want you to be pretty confident in your ability to do story problems, okay, or word problems. The ladder example is a typical example. So it says a ladder is leaning against the house, and it makes an angle of 60 degrees with the ground. The foot of the ladder is 7 feet from the foundation of the house. How long is the ladder? So there is my house. I know that the ladder is leaning up against this house, and I know that the angle it makes with the ground is 60 degrees. Okay, the foot of the ladder is 7 feet from the base of the house. How long is the ladder? That's the ladder. So there's a couple ways you can do this problem. You could recognize that, hey, this is a 30, 60, 90. And since that's my shortest side, to go from short side to hypotenuse, multiply by 2. So I know that x right now has to be 14 feet. Okay? If you know that relationship, you're done. However, I feel like most of you probably will not remember that relationship down the road. So again, the foolproof way to do these problems, in other words, the way that will always work, is to use SOHCAHTOA. So suppose I don't recognize it's a 30, 60, 90. Well, here's my angle. I have my adjacent side, and I want to know my hypotenuse. Okay, adjacent hypotenuse tells me to use cosine. So cos 60 equals adjacent over hypotenuse, cross multiply, 7 equals x times cosine 60. Divide both sides by the cosine of 60 to get x by itself. And you end up with x is roughly, and again, just plug that stuff right there into your calculator. So 7 divided by cosine 60, hit enter, and sure enough, you should get 14 feet. And this is not an approximation, so this thing actually should not be squiggly. It should be equals, because it's an exact answer. Okay? So there we are, a typical ladder problem that involves SOHCAHTOA. And finally, the very last example that we're going to look at down here, number 4. Give me a second here, I apologize. So for number 4, it says a balloon on a 40-foot string makes an angle of 50 degrees with the ground. How high above the ground is the balloon? Okay. Oh, I take that back. How high above the ground is the balloon if the hand of the person holding the balloon is 6 feet above the ground? So that adds a whole nother element. But long story short, what we're really looking at is this. Okay. Here's a person, right? They're holding a 40-foot balloon, and it makes a 50-degree angle with the ground. So if that's my ground and that's my balloon, I know that this is 40 feet long. Let me erase that excess piece there. And they tell me that this angle here is 50 degrees. And so the question is, how high above the ground is the balloon? So in other words, I'm looking for this height right here. Okay, call it x. All right, so again, now I go back to my typical problem. Here's my angle. I want to know the opposite side. I know the hypotenuse. Opposite hypotenuse tells me I'm using sine. So sine 50 equals x over 40. Put this over 1. X equals 40 times the sine of 50 degrees. And again, at that point, grab your calculator. 40 times sine 50. Hit enter. And you get roughly 30.6 feet. And the trick here is to recognize that the hand where the balloon is being held, so this point here and this point here, are both 6 feet above the ground. Okay, so there's an extra 6 feet there. So once I'm done, I have to account for that additional 6 feet by adding it onto my answer. And so the balloon is actually 36.6 feet above the ground. Okay, roughly. So anyway, so hopefully this is a pretty good introduction here to this idea of story problems involving SOHCAHTOA. And again, when you come into class tomorrow, we have 12 additional examples that we'll look at in class to make sure you all feel confident in your ability to solve various story problems.